Okay, in this video, I'm going to, this is the first part of what I call the triple threat of linear equations. And basically, you need to be able to, when given one of the following, either a table, a graph, or an equation, you need to be able to produce the other two. If you can do that, you have half of Algebra 1 in the bag, I think. So this video is about if you are given an equation, a linear equation, you need to be able to produce a table and then graph that equation. And you could do one or the other, but I think it's easier a little bit to do the table first. So here's my equation, y equals 2x plus 5, okay? And the first thing I want to do is I'm going to make a table for the values for this linear equation. Okay, so I'm going to set up a table. Give myself an x and a y. Now, commonly, easy values to use. Well, sometimes easy values to use, especially if there's not a fraction in for your x. Okay, then sometimes the easier values to use are -2 for your x, and -2, -1, 0, 1, and 2. That usually makes the math a little easier, the numbers a little smaller. But after you do these for a while, then you tend to kind of start to know when this is going to be easier and when it might be easier to use different numbers. So for this one, I'm going to use these numbers in for x. Now, if I and I kind of made those up. -2, -1, 0, 1, 2. So what I need to do now is, if x is -2, okay, I need to plug in -2 into x in my equation and then solve for y. And then that will tell me the coordinate for this linear equation. What is one of the coordinates when x is -2? What is y? So I'm just going to use kind of scratch pad over here. Y equals 2, and then for x, in this case, I'm going to put -2. Plus 5 is the rest of the equation. So 2 times -2 is -4. I have the plus 5 over here. So -4 plus 5 is 1. So I know that when x is -2, y equals 1. And then that's one of the points in my on my line. Now, if you want to double check that, what you can do is plug in -2 for x, plug in y for 1. If you solve that, the left side and the right side of your equation should be equal. So if this was 1, right, and x is -2, we can see -2 times -2 is -4, plus 5 is 1, and that's 1 is over here. 1 equals 1. That's true. Now, what if x is -1? Well, then I'm going to put in x is -1 into my equation. 2 times -1 plus 5. Then I'm going to solve again. 2 times -1 is -2. -2 plus 5, that gives me 3. Y equals 3. So, if x is -1, y is 3. I don't know if I said -3. Y is positive 3, right? -2 plus 5, 3. So x equals -1. If x is -1, y equals 3. Again, this is a relationship, right? If x is -2, y is 1. If x is -1, y is 3. If x is 0, what's y? Well, that one's easy. Not only is it the y-intercept, by the way, but also if x is 0, 0 times 2 is 0. 0 plus 5 is 5, so if x is 0, y is 5. And again, I knew that already because this is written y equals mx plus b, the slope-intercept form of the equation. And if it's written y equals mx plus b, b is the y-intercept, and the y-intercept is 0, wherever it crosses the y, 0, 5. Now, let's do two more. I think we can start to do these in our head. If x is 1, 2 times 1 is 2. 2 plus 5 is 7. So if x is 1, y is 7. And then last but not least, if x is 2, 2 times 2 is 4, 4 plus 5 is 9. So if x is 2, y is 9. Now that I have my table, I can go ahead and graph this, and all I need to do is set up a coordinate plane with my axes, okay? And you should do this on graph paper, but for the sake of time, I'm just going to go ahead and plot some of these for you. Oops. You can get the idea. Okay, positive, right? Negative 2, comma 1. That'll be right here. Negative 1, comma 3. 1, 2, 3. 0, 5, 1, 7, and then you can kind of see the pattern. Now I just graphed that, and I made a table and a graph from an equation. So let's see if we can do one more rather quickly. Again, just pause and re-watch if we're going too fast for you. Okay, I do want to make the most of our time here. Let's say y. We'll do a really tricky one. Y equals negative 2 thirds x plus 3. Now, I said last time that we use the values negative 2, negative 1, 0, 1, 2. In this case, we have a fraction as the slope, and that's going to probably make it pretty messy for me. If I try to use negative 2, then all my y values are going to, or some of my y values are going to be fractions, and that's kind of hard to graph. So if I see here that it's negative 2 over 3, I'm going to pick x values, okay, that are a multiple of 3. And the reason why I'm going to do that is if my x values are a multiple of 3, then I know when I plug them in for my x, and then I multiply them times this fraction, the multiple of 3 is going to cancel with the denominator 3. And I'll show you what that kind of looks like. So what I'm going to do is I'm going to say my x's are negative 6, negative 3, 0, 3, and 6. Okay, those are all multiples of 3. So now I'm going to plug those values in for my x. So if x is negative 3, then I have y equals negative 2 thirds. Let's choose x is negative 6, okay, plus 3. I just put negative 6 in for my x. So now you can see negative 2 times negative 6 is positive 12, divided by 3 is 4. And then I bring down the plus 3. So if x is negative 6, my y is going to be 7. Can you see how that was a nice even, it turned out to be a nice even whole number because I used multiple of 3 for my x. Let's do another one. Okay, if x is negative 3, well, negative 2 thirds times negative 3 for my x plus this 3 up here. This 3 is just, it could be 4, it could be 5, it just happens to be also 3, but that doesn't, the main thing that I'm looking at these is this 3 in the denominator. Okay, so negative 3 times 2, negative 2, don't forget this negative, is a negative, positive 6. Positive 6 divided by 3 is 2. So I have y equals 2 plus 3, y equals 5. Okay, now I know this is written in the slope-intercept form. So this should be my y-intercept, because if x is 0, all of this cancels to 0, y equals 3, okay? If x is 3, 3 times negative 2 is negative 6, negative 6 divided by 3 is negative 2, plus that 3 over there. If x is 3, y is 1. And you can solve the last one, but I have a good feeling that what I'm going to get is negative 1, okay? Now I have my table. I can simply graph this line, right? Here's my y, here's my x, 0, 3 is my y-intercept. Another coordinate is 1, 2, 3, 1. Another coordinate is 6, -1. Another coordinate is -3, 5. Okay, and then -6, 7 will be somewhere up here. And now I have, once again, graphed the line given the equation. Let me make one more final note. Here's my equation, okay? Without even making the table, I can also graph this line very easily. I start at my y-intercept, which is the y-intercept, y equals mx plus b. It's 0, 3. So I start there. Now what I do is I take my slope of -2/3 and I can go down 2, right 3 and draw a dot or a point, or I can go up 2 and left 3 and draw a point, up 2, left 3. And that will be another way to graph this line given the equation as well. All right, I hope that wasn't too fast. It makes sense. As always, thank you for watching.